Okay, Bismillah ar-Rahman ar-Rahim. Welcome to another live A-level lesson. Today's topic is algebraic long division. Let's start off with just a simple division where we've got just numbers, just to see if you can comfortably do this. So let's say I'm taking 5 and I'm dividing that into 30821. If you can just have a go at that. And I'll just quickly check. Yeah, that's fine. Audio settings are fine. Okay, so hopefully you've had a chance to at least take a look at that. So the way you probably did this at school was how many fives go into 3, and that's none. And then how many carry the 3 forward, how many fives go into 30. So we're looking at 30 now. That's 6, no remainder. And you carry on like that. A better way of laying that out, but it just takes longer, but it's clearer to see, so it's worth learning, and also you're going to need it for what we're about to learn for algebra. How could we lay it out much more clearly? We could say, look, how many fives go into 3? It's nothing. And then how many fives, and then carry the 3 forward. So how can we show clearly that we're carrying the 3 forward? We could do 0 times 5 is 0. And then if we take that away, we've got 3, take away the 0 is 3. And then we can bring down the next number, which is a 0. So now we've got how many 5s go into 30. That's where the 30s come from, because 0 times 5 was 0, and 3 take away 0 was 3. Bring down the next digit, 30. How many 5s go into 30? That would be 6. What is 6 times 5? Well, it's 30. And then you work out the remainder, which in this case is 0. So then you bring down the next number, which is the 8. And then how many 5s go into 8? That's going to be 1. What is 1 times 5? It's 5. So we can write that in, and then we can work out the remainder. So we can keep going like this, and it's just a really clear way of showing what is the remainder at each stage and what is it that we're bringing down. And now we're going to try and use that technique in algebra. So with numbers, it's not too important because you're just going to use a calculator. But what if you have something like x cubed, which I'll put in a second, plus x squared minus 7 and we want to divide that by x minus 3. So you won't need to learn anything new. We're going to use the same technique, but this time within the division we're going to have algebra on the inside and the outside. Let's have a go. So the x cubed plus x squared minus 7 will go in here, and the x minus 3 will go in here. Remember that division, another way of doing divide is just to think, what do I need to times by? So let's have a look at the first thing. We're doing x cubed divided by x minus 3. In other words, what do I need to times by? What do I need to times the x minus 3 by to get something even close to x cubed. It doesn't have to be exactly x cubed, just x cubed, but the x part definitely has to be x cubed. So just think x take away 3 times what would make x cubed. There's only one possible answer here, and that's x squared. Because the x, at least the x part, when I times that by x squared, I'm going to get x cubed. And now you do it backwards and you say, okay, well, what is x squared times x minus 3? Just like before, so what is x squared times x minus 3? Let's do that in green. That's going to be x cubed from the x squared times the x, and then take away 3x squared. And just notice that it goes x cubed, x squared, and then a number. That means there's something missing. So the minus 7, we're just going to shift across, and a little bit later, we're going to need to know that that's actually 0x. Otherwise, we're going to have something missing. So let's fill that in now before we get too far. So now we can work out the remainder. So we can do this. We've got x cubed take away x cubed is nothing. X squared take away minus 3x squared. That minus turns into a plus. So it's 4x squared. And then we can bring down the 0x. Okay, same question again. Instead of looking at the x cubed now, we are looking at the 4x squared plus the 0x. And we're going to ask the question that what do I need to times x minus 3 by to get 4x squared plus 0x? And remember, you don't have to get an exact match, but at least the x squared part has to be very, very close. So we've got x times 4x should do the job. So let's have a plus 4x here. And you always have to do this in two movements, two parts. You're thinking, what do I need to write here? And then whatever you do right here, you have to then times back with what you've got at the beginning. So let's take the 4x and times back. We've got 4x times the x. That makes 4x squared, which is great, which is what we wanted. And then we've got 4x times the minus 3, which is minus 12x, which isn't what we have up at the top here, but that's okay. It's the way it works. You just end up with a remainder, which allows you to carry on to the next bit. So subtract the 2 to figure out what the remainder is. We'll have 4x squared take away 4x squared means we're going to have nothing. And then 0x take away minus 12x, that is going to be 12x. I'm going to pause here and ask, what is the next step? So just take a look at the way we did this. The difference in the color should try and help you what we're doing at each step and what we're focusing on, what we did focus on in the last two occasions. So what do you think we'd need to do next? Type it into the chat box if you can. Okay, it's just the bringing down. So on the occasions before, when we took what we had written at the top and multiplied it we then just, if we didn't have too much, we would just bring down, sorry, and then multiplied it, then worked out the remainder, then we would just bring down the next thing. So here we've worked out the remainder. We just need to bring down the next thing, which is the minus 7. And then comes your focus. So your focus now is really on the 12x minus the 7. And you're comparing that and thinking, what do I need to times the x minus 3 by to get to 12x minus 7? Have a think. If you can work that out, type that into the chat box. Just let you have a think of that. So it's x minus 3 times something to get close to 12x minus 7. At least the 12x has to match. So the answer here would be, I need to times by 12. At least that way the x times by 12 will get the 12x. So it's just a 12 I need. And now, remember I said you have to do this kind of thing in 2 movements. As soon as you write that answer at the top, you then take it back and multiply out. So it's 12 timesing by the x minus 3. So that's 12x. And then the 12 times the minus 3 is minus 36. What do I do next? Okay, a little bit quiet today on the chat messaging, but it's the first time you've seen this, so maybe you just need to see it all in one go and then try little bits yourself. So here we are working out the remainder. Do we need to take anything down yet? No, we just want to work out the remainder as soon as you've done that multiplication. So there's nothing on the x. Minus 7 minus 36. Very easy to forget. There's minuses here, here, and here. So just remember that. I'm going to rub them out because too many minuses, you might get confused what's minusing what, but it's the whole thing being minused. So the minus 7, take away the minus 36. That is going to be minus 7 plus 36, which is going to be 29. And then at this point, you normally take down the next bit, but there is no next bit, so we can just stop there. So that's your answer, that if I need to do x cubed plus x squared plus 0x minus 7 divided by x minus 3, I'm going to get x squared plus 4x plus 12 plus a remainder of 29. Now, how do you show a remainder? If you remember when you were learning division at primary school and you had something like 4 into 15, first you learnt it with a remainder, so 4 into 1 doesn't go, carry the 1 across, 4 into 15 goes 3 times, but it's not perfect, there is a remainder of 3. So that's how you write it initially, but as you learn a little bit more, you can then rewrite that as, it's not 3 remainders 3, it's 3 and 3/4. There's your 3 remainder. And why have I got, where did I get the quarters from? Because I'm dividing by 4. So a similar technique here. We can say that the answer to the division is x squared plus 4x plus 12. But I've got this remainder here of 29. This remainder here of 29. So I can just write plus a remainder, which is 29. It's 29 as a fraction. As a fraction of what? A fraction of, just take a look at what I'm dividing by. It's x minus 3. So we can just write x minus 3. Okay, quite a lot to take in. Let's see how you did. Let's see if I can just rewind that back. And what I want you to tell me is, what is the next step as I go through that division? Okay, that's as far back as we'll go. So you can see some of the main steps. And here I am. I've done the subtraction. So I've got 0x 4x squared take away 4x squared is nothing. 0x take away 12x is 12x. Sorry, 0x take away minus 12x. There's two minuses. So that becomes a plus 12x. And then I'm just about to bring down the minus 7. Fantastic. Okay, so what happens next? See if you can write it in. Okay, you got to take a guess. What happens next? What's the next step I did? Okay, still a little bit quiet. So the next step I did is I focused on the 12x minus 7 with the x minus 3, and I said, what do I need to times the x minus 3 by to try and get 12x minus 7 as close as I can? And it was times by 12. Then straight away I did something with that 12. What did I do? I took the 12 and I times it by the x minus 3. Every step, you're taking whatever you're writing at the top and timesing by that thing you're dividing by. So that's 12 times x is 12x. 12 times minus 3 is minus 36. Okay, what did I do next? The layout should help you, one underneath the other. It's to do the subtraction. So you end up with figuring out what you've got left over. Here, the 12x take away 12x is nothing. Minus 7 minus minus 36 is 29. And then if you had more to the expression here, you would just bring the next bit down. But here, we can stop and we can just write the remainder of 29, just like any number dividing by, write it as a fraction over what you're dividing by. So here, the 29 as a fraction of what we're dividing by. Okay. So that's the first example on algebraic long division. Have a look over it again if you got a little bit lost, and we'll do more tomorrow, inshallah, God willing. Assalamu alaikum.